Alright, second question. So we'll have three problems here. Each problem you will have to use a different method to prove that this sequence is convergent. For number one, the method we'll use here is the pinching theorem. To pinch this an, you have to use the fact that sine n is between -1 and 1. So we have an is less or equal to n plus 2 over n minus 2 over n plus 1. Okay, just replace this as sine n with 1. You'll have what we have on the right side, and it is also greater or equal to n minus 2 over n plus 1. This is because you can replace this sine n with -1. Now, once you have this pinch, try to evaluate the limit of both sides in this inequality. Obviously, both of them are equal to 1. So by the pinching theorem, the limit of an is also equal to 1. Again, we use the fact that sine n is between -1 and 1. For the second one, we'll have to show that at some point this sequence is decreasing, and we also have a lower bound of this sequence. To prove that this sequence decreases from some point, you can try to write down a few terms in the sequence and give a reasonable argument to show that this sequence decreases. Okay, the first term in this sequence is b1 equals 3 over 1 factorial, which is 3. b2 is 3 squared over 2 factorial. Or you can rewrite this as 3 over 1 times 3 over 2. Since 3 over 2 is a number greater than 1, and 3 over 1 is just b1. So b2 is greater than b1. Now, let's keep going. b3. By this formula, b3 is 3 cubed over 3 factorial. You can again rewrite it as 3 squared over 2 factorial multiplied by 3 over 3. This is because 3 squared times 3 is 3 cubed. 2 factorial times 3 is 3 factorial. And now, this time 3 over 3 is 1. And this term here is exactly b2. So b3 is the same as b2. If you keep trying, then you see that b4 is equal to 3 to 4th over 4 factorial, which is 3 cubed over 3 factorial times 3 over 4. And 3 cubed over 3 factorial is B3. And 3 over 4 is a number less than 1. So the product will be less than B3. If you keep trying, B5, 3 to 5th, or 5 factorial. And that is equal to 3 to the 4th over 4 factorial times 3 over 5. For the similar reason, it is less than B4. Okay, because this is B4, and this is a number less than 1. So now you can make a conclusion and say that Bn, the sequence, decreases when n is greater than 3. So the first part of this argument is done. We show that Bn decreases at some point. And then we need to show that this Bn has a lower bound, which is obvious because this is definitely greater than 0. So, because the Bn decreases and has a lower bound, you can see that Bn has a limit. Now let's try to find the limit. Write down a relation between Bn plus 1 and Bn. Bn plus 1 by definition should be 3 to the n plus 1 over n plus 1 factorial. Rewrite this expression as 3 to the power of n over n factorial times 3 over n plus 1. Here we use the fact that n plus 1 factorial is equal to n factorial times n plus 1. And this part, this first factor is just Bn. So we have Bn plus 1 equals Bn multiplied by 3 over n plus 1.
No, no worries. I was just checking for the flight.
Now we'll start to take the limit on both sides in this equation.
Oh, she's been here for quite a while. She's my second.
The limit of the left side
But yeah, I mean, we're
is the same as the limit of Bn. The limit of the right side is the limit of Bn
they live like
multiplied by the limit of 3 over n plus 1.
Somehow it's kind of a slightly odd building. We were just discussing last night.
And we know that the limit of 3 over n plus 1 is equal to 0. So the right side in this
I'm sure
equation
somebody is thinking about that.
is
But
equal to
it would
0.
actually be incredibly difficult.
No matter what this is.
Why?
Well, there are a
You
bunch of
multiply by
payments
0,
to
you get 0.
Oh.
sue you and
Oh, I see, I
like
see.
I mean, you know, the building is like poured concrete.
So we are done. The
It'd be
limit
very
of
hard to
Bn
reconfigure
is equal to 0.
things. Everything is laid out in this kind of weird, old-fashioned way.
I
Like,
see.
you know, somehow the apartment feels, you know, it's got the like Frank paneling. It looks very.
For the third question,
I see.
Which is fine for that. But
we will use the
make a bunch of money.
basic result or
You would have to do a lot.
definition of E.
Yeah, the real estate is not way for readers.
Yeah.
I will leave it here,
Place, but I mean,
but you don't have to write in your answer, which is
something about it.
E equals the limit of 1 plus 1 over n to the power of n when n goes to infinity. The difference between the result here and the quotient here is that the numerator in the parentheses here is not 1 but 4. So we'll do some algebraic trick to make our sequence close to this one. First, write down this expression. And then you divide both the numerator and denominator by 4. Yeah. So once you did that, you can define, introduce a new letter m as n over 4. Now obviously n is equal to 4m. So the limit of 1 plus 4 over n to the power of n when n goes to infinity is the same as the limit of 1 plus 1 over m, because n over 4 is m, to the power of n, which is 4m. Be careful here. We should write m goes to infinity instead of n. Be careful. Now what is the limit of this one? It looks similar to what we have here, but the exponent is not m, but it's 4m. So we rewrite it as 1 plus 1 over m to the power of m, and then to the 4th power. Inside the bracket, the expression here has limit e, according to what we have here. So the limit of the whole expression is e to the 4th.